Good evening, Sir Duarte and classmates. My name is Juan Miguel MATITO, and this is my lesson on Wallis reduction formula. This formula is used for three things: evaluating the integrals of cosine to the n power of x and cosine to the n power of x. We're working with trigonometric functions and understanding the behaviors of trigonometric functions. This is the equations that we will be using today. The first is the integral from 0 to pi over 2 sine to the n power of x dx, or the integral from 0 to pi over 2 cosine to the n power of x dx equal to in, and in is equal to n minus 1 over n times in minus 2. So basically, what this means is that we'll repeatedly reduce the powers of either sine or cosine until we reach 1 or 0. And this is the values of I1 and I0. I1 is equal to 1, I0 is equal to pi over 2. Something to remember is that if your power is odd, then you will always end up with I1. And if you are even, you will end up with I0. Let's start with our first example. Integral from 0 to pi over 2 sine to the 6th power of x dx. Following the formula, we would first end up with 6 minus 1, which is equal to 5 over n. N is 6, so 6 times in minus 2. 6 minus 2 is 4, so it would be times I4. Then we would reduce I4 again until we reach I0, because I4 is an even number. So 5 over 6 times 3 over 4 times I2 equals to 5 over 6 times 3 over 4 times 1 over 2 times I0, which is equal to, as you remember, pi over 2. We just add, so it would be 15 pi over 96. And that is it for our first example. On to the second example, and in our last one. The integral from 0 to pi over 2 sine to the 5th power of x plus cosine to the 8th power of x dx. We can rewrite it as the following. The integral from 0 to pi over 2 sine to the 5th power of x plus dx plus the integral from 0 to pi over 2 cosine to the 8th power of x dx. Then we solve both separately. The first, the integral from 0 to pi over 2 sine 5x dx is equal to, following the formula, 5 minus 1 is 4 over 5 times in minus 2. It is I3. Then we keep going until we reach I1. 4 over 5 times 2 over 3. 3 minus 2 is 1, which ends up with 1. So we can just write 1 already. And our answer would be times all of this, 8 over 15. And that is it for the first part. On to the second part. The integral from 0 to pi over 2 cosine 8 of x dx is equal to, following the formula again, we have 7 over 8. 8 minus minus 2 is I6. Then we keep going. 7 over 8 times 5 over 6. I4 equals 7 over 8 5 over 6 times 3 over 4 times I2. The 7 over 8 times 5 over 6 times 3 over 4 times 2 over 1. 2 minus 2 is 0, so we would end up with pi over 2 times pi over 2, which is equal to, in total, 105 times pi over 384. Then we can just combine our two answers. It would be, this is our final answer, 8 over 15 plus 105 times pi over 384. That is it for my lesson today on Wallis reduction formula. Thank you for watching, everyone, and have a nice day.